Hello and welcome to Daud's Networking Labs. Today is CCNA 200-301 day 14, and today we will be covering routing and forwarding decisions. Okay, so basically we're going to be covering 3.2, which is determine how a router makes a forwarding decision by default. And in the subsections is 3.2a, longest prefix match, 3.2b, administrative distance, and 3.2c, routing protocol metric. So we're going to cover all these in this video. Alright, let's do this. Okay, so longest prefix match. Longest prefix match, or LPM, is the primary method used by routers to select the best route to forward a packet. You need to know this. This is super important. And it's a simple topic. It's just longest prefix match. Which one matches the prefix the best? In this process, the router looks for the routing table entry that has the longest matching prefix for the destination IP address of the packet. This method ensures the most specific route is chosen. So an example would be, say the destination IP is 192.168.1.45, and this is your routing table entry. It's 192.168.1.0/24, and this one is 192.168.1.0/25. So in this case, the router will choose the /25 entry because it has the longest prefix match, which is 25 bits. It's 25 more than 24, so this is the longest prefix, which means this will be the longest prefix match. Alright, what is administrative distance? Administrative distance is used to determine the trustworthiness of different routing protocols. When multiple routing protocols provide routes to the same destination, the router uses administrative distance to select the best route. The route with the lowest administrative distance is preferred. So administrative distance is the number you'll see in a routing table, and if all the prefixes match, or say two of them are the same prefix and it's like they're both matching, then you look at administrative distance. So in this case, an OSPF route would be the administrative distance of 110, RIP would be 120, EIGRP would be 90, and in this case the router will choose the EIGRP route because it has the lowest administrative distance, which is 90. Default administrative distances. So let's just go over all of the common ones you'd see, right? There's a connected interface, which is a directly connected network, and it's an administrative distance of 0, which is the lowest. Then there's a static route, which is a manually configured route by an administrator, which is an administrative distance of 1. There's an enhanced interior gateway routing protocol, or EIGRP, summary route, which is 5, and it's summarized routes in EIGRP. Then there's external border gateway protocol, or BGP, which is an administrative distance of 20, and it's routes learned from external BGP peers. Then there's internal enhanced interior gateway routing protocol, which is EIGRP normal, and it's 90, and it's routes learned from within the same autonomous system via EIGRP. Then there's IBGP, or internal border gateway protocol, which has an administrative distance of 200, and its routes learned from internal BGP peers within the same autonomous system. Then there's OSPF, which is open shortest path first, has an administrative distance of 110, and its routes learned via the OSPF protocol. Then there's intermediate system to intermediate system, or IS, which is an administrative distance of 115, and it is routes learned via the IS protocol. Then there's routing information protocol, which is RIP, administrative distance of 120, and this is routes learned via the RIP protocol. You need to know most of these, but as long as you have a similar gist, you need to know like the important ones. OSPF is 110, routing RIP is 120. You honestly have to memorize all of them, if I'm being honest, but like if you get a feel for the main ones, then you can figure it out and like cancel out a couple. That's how I did it, at least. Then there's NA, which is the final, and it's unreachable. Administrative distance is 255, and it indicates an unreachable route. Then there's exterior gateway protocol 140, and it's how they're learned from EGP. I don't think you need to know these ones. I never saw these ones, never really memorized them, but it's good to know if you're an enthusiast of learning networking. On-demand routing, ODR 160, and then this one, yes, you need this one. External Enhanced Interior Gateway Routing Protocol, or EIGRP, is 170. because it is routes learned from external EIGRP automatic system or autonomous systems. So, routing protocol metric, what is it? When the longest prefix match and administrative distance are equal, the router uses the routing protocol metric to make the final forwarding decision. Each routing protocol uses its own metric to determine the best path. So, let's give an example. 2 OSPF routes to 192.168.1.0/24. Path 1 has a metric of 10. Path 2 has a metric of 20. In this case, the router will choose path 1 because it has a lower OSPF metric. And these can all vary. For EIGRP, it's a different one. For OSPF, it's different. For RIP, it's different. But if you want to get super in detail, I'd probably suggest Jeremy's IT lab for this. I'm just giving you the main coverage. And yeah. Then it's a combined decision process. That's how it works. So this is like in total if I'm telling you everything. First, it looks at the longest prefix match. The router first looks for the routing table entry with the longest prefix match that matches the destination IP address. If there's more than one same longest prefix match and they're both equal, then it looks at administrative distance. And if multiple routes are found with the same prefix length, the router compares the AD values or administrative distance values and selects the route with the lowest AD. If that also is the same, then routing protocol metric comes in, and if multiple routes still remain within the same AD, the router then compares the routing protocol metrics and selects the route with the lowest metric. So, let's go through an example. There's a destination IP address of 192.168.1.45. The routing table entries are OSPF 192.168.1.0/25, metric 10, AD 110. Then there's EIGRP, which is 192.168.1.0/24 in the metric of 20 and an administrative distance of 90. Then there's RIP, which has an IP address of 192.168.1.0/25. The metric is 15 and the administrative distance is 120. The router will select routes with the longest prefix, 192.168.1.0/25 from OSPF and RIP, because these are both 25. So EIGRP is out of the conversation. Now, we'll compare the administrative distance. OSPF is 110 and RIP is 120. So OSPF is preferred because it has a lower AD. Right? Administrative distance 110, 120. So you want to go with OSPF. So routing decision. The router will forward the packet via OSPF route of 192.168.1.0/25 with a metric of 10. This process ensures that routers make the most efficient and accurate forwarding decisions based on this most specific, trustworthy, and optimal route available. This is the key. You need to understand this, and I beg you to understand it. There's also better YouTube videos, not better, but there are other YouTube videos, and they can go in more detail because this is an overview. But if you want to go really in detail, go search up routing tables, go around a couple of videos, and you might find some with practice. You need to practice this. This is very important. Also, go through Passimo. You can target IP connectivity, I think is this server. And that will probably find a bunch of questions on it. I really suggest you know this by the back of your hand. Alright, thank you so much for watching. If you like this channel, please like, comment, and subscribe, and let me know if you have anything else you want to watch, because I'm doing this class for you guys, so let me know. Thank you for watching, and see you soon.